In this video, we'll be looking at even and odd functions. Now, let's start off by looking at even functions. So in an even function, if we have f of x, that's actually always going to be equal to f of negative x. Now, what do I mean by this? So let's look at the cosine curve, because the cosine curve is actually an even function. Notice how if you look at the y-axis is actually a perfect mirror for the cosine curve. So the cosine curve looks like this on the right side, and it looks the exact same way on the left side, which means that it doesn't matter what x is. So let's say x is over here. I'm just going to choose a random point. Let's say x is right here. On the other side of the graph, negative x is over here. Or y value or f of x value is actually going to be the same whether you are on the positive side of the graph or on the negative side of the graph. So otherwise saying an even function is going to have the y-axis as a perfect mirror. Now the odd function is slightly harder to explain, but it's not so bad. So we're still looking at how our y-axis is acting kind of like a mirror, but instead of mirroring it exactly, it's going to mirror it but upside down. Let me explain what that means. So in an odd function, which the sine curve is, or f of negative x value will actually be negative f of x. And remember that you can think of f of x as just y. So let me explain what that means according to the graph. So let's say, for example, our x value is right here. So the y that goes with it would be up here. So on the other side of the graph, so mirroring over on this side of the graph, our negative x value would be matching with an opposite y value. So the quantity is still the same. The y value here is still the same quantity-wise, absolute value-wise, but it is going to be negative now. So basically, our y-axis is acting kind of like a mirror, but then you're flipping the graph upside down. So the original sine curve looks like this, and then when you look at your mirror right here, everything is flipped upside down, and that's how you know it's an odd function. So that's what it looks like visually, but let's see how to figure out if a function is even or odd or neither algebraically. Okay, so there are two ways to determine whether or not a function is even, odd, or neither. The first way is the way that we looked at just now. So if the y-axis is a perfect mirror, then it's going to be even. If the y-axis is kind of like, so let's sketch this out actually. If the y-axis is a perfect mirror, so if it looks kind of like this, perfectly mirrored, well, that's my attempt at perfectly mirrored. If it looks like that, then it's going to be even. If instead, when it hits the y-axis, it does something like that and does a mirror but upside down, then it's odd. And if it's not doing that at all, if the y-axis is not acting like any type of mirror at all, so maybe the graph looks like this, since the y-axis is not the mirror or the axis of symmetry, then that would be neither. So again, just making sure we get this. This is even, this is odd, and this one is neither. But sometimes questions want you to do it algebraically, so that's what I really want to talk about now. Okay, so as you can see for even functions, if you substitute negative x, it's the same exact thing as if you substitute positive x. So we can actually take negative x and plug it in for x and see if we get the same exact function. If we do get the same exact function when we plug in negative x, that means it's even. Now, if we plug in our negative x, if we substitute negative x, and we get the opposite value, so the opposite sign, then the function will be odd. So let's give it a try. All right, so I am going to, our original function here is negative 3x squared plus 4. I'm going to go ahead and substitute in negative x for x. So we have y equals negative 3 times negative x squared plus 4. And here we have, when we simplify, negative 3. When you square negative x, it's actually x squared plus 4. And as you can see, the new function is the exact same thing as the old function. And so since they are the same, as you can see here, the function that we just tried is even. Now, if, again, I'll just reiterate, if we had done this work and we had gotten this to be the opposite sign, then the function would be odd. If we had done this work and the function was entirely different, if it wasn't the same at all, then the function would be neither even nor odd. All right, hope that made sense.